right. Today we're going to talk about transformations and we're going to begin our transformation unit. So let's see what we're talking about here. Well, I'm giving you out a packet that has a bunch of pages that you need to fill out. So we're going to have some rules that we need to abide by to keep these packets in good condition and make sure that they're filled out correctly. So first of all, we want you to complete all the notes that we give you, complete all the worksheets, and then once you've done that, you're going to put all the answers on Canvas. So you're going to post them on Canvas. And at the end of this whole thing, you're going to turn in your packet in good condition, and you're not going to lose it in this process. So this packet's important. It covers the entire unit. So the first page looks something like this. And it has some little places or boxes to fill in that talks about geometric transformations. So let's take a look at that page. And you're going to fill in these particular blanks with these words. So to transform a shape or figure is to change it. In general, we can change the size, location, and direction that a figure is facing. The shape or figure before the transformation is called the pre-image or original, and we might label it A, image A. The shape or figure after the transformation is called the image or new figure. We would then label it A with a little mark at the top, like a little exclamation point or something, but pronounced A prime. So now if you look at these different kinds of translations, if we just take this little smiley face from the upper right-hand corner and just drag it down to the lower left-hand corner, that's called a translation, okay? If you look at this one, you can notice that this little face has been reflected, and in this case, reflected across the y-axis. The next one, all we did was we rotated this face from down in this quadrant up into this quadrant. And if you notice, the face kind of rotates with it and it gets turned on its side up here. And then the last one, when we change its size by multiplying all of the coordinates in the shape by a particular factor, that's called a dilation. Now down here where it says keywords, those are the keywords that I put at the top. So if you want to write them up here, that's fine. Or if you want to write them down there, that's fine. Okay, so where do we see transformations in the real world? Let's look at some examples. Well, for translations, we see the movement of airplanes or cars or something just going down the road. They just go straight down the road, and sometimes they'll go around a curve or something, but they're pretty much staying in the same orientation and just moving around. Elevators going up and down is an example of that, or cars driving, as I mentioned. Reflections of light. For a reflection, sometimes you'll look at a mountain reflected into a beautiful serene lake, and there's a reflection of some light off of the water. Sound waves, when the sound waves bounce off of an object and reflect back. Or parabolic mirrors like your car headlights and things like that. Rotations is when an object is just rotated around a center point of some kind, such as a Ferris wheel or the wheels on a car. If you look at the rim on a car, as you can see these same shapes that are just rotating around the center of that rim. And then, as we mentioned a moment ago, dilations are used in things like graphic design, so they can enlarge or shrink an object and make it look a little bit fancy that way. Another place where they're used is in crime investigation. So sometimes they'll take a crime scene and blow it up so that you can actually see it in greater detail. So dilations that we're talking about mostly in this lesson are when you take a smaller object and make it bigger, or a bigger object and make it smaller. So when you get done, they are similar figures, and they have the same angles, but they're just proportional in size. Okay, so in dilations, a transformation in which the figure is made bigger or smaller with respect to a fixed point called the center of dilation. The pre-image and the image are smaller but not congruent. Now, if you're watching at home, you can click on a link like this, and then there's another little video about it that will help you see it in greater detail. So here's a few more definitions. So taking a look at your notes, remember to put your name, date, the topic, and the class on it. So the enlargement or reduction of a figure is what we mean by a dilation. The number that we use to indicate how much we are going to enlarge or reduce it is a scale factor. We usually use the letter K for constant. When that number, that K, is bigger than 1, the dilation is an enlargement. But when it's a fraction or that is less than 1, that dilation is a reduction in size. And dilations do result in similar figures. So, for example, if you look at the stuff on the left here, if I wanted to double the size of that image, I just multiply everything in there by 2, a dilation of a factor of 2. So multiply each of these coordinates by 2, and that ends up with the new coordinates of the new image. So there we go. So let's try a couple of these, and we'll do the best we can. Keep in mind, though, that I'm not going to be able to do all of them because it's just a little difficult on a keyboard and a mouse. So for the first one, triangle ABC with vertices -3 and 4, B is 2 and 1, and C -1 and 5. If we enlarge it using a scale factor of 2, then that's what we're going to do is we're going to multiply all of those numbers in there by 2. So let's kind of describe that. We're going to multiply each coordinate in these 3 pairs by 2. So what would that look like? So the first one would become -6 and 8. The next one, 2 times 2 is 4, and 2 times 1 is 2. 2 times -1 is -2, and 2 times -5 would be -10. So it's pretty straightforward to get to, if you're multiplying by an integer like 2, to come up with your new coordinates. Then you just graph them, -6 and 8, so 1, 2, 3, 4, 5, 6, and 2, 3, 4, 5, 6, 7, 8. You'd put a dot there. Then 4 and 2, 1, 2, 3, 4, 1, 2. And -2 and -10. So -2 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That takes us clear down to the bottom, doesn't it? So if we get our line tool, and we can just draw some lines in between these. And we can get our new shape. So now this is the enlarged image right here. But what about the original image? We didn't plot that one. So let's get a different color, and let's plot that one. So we got -3 and 4. So -1, 2, 3, 1, 2, 3, 4. 2 and 1, over 2 and up 1, over 2 and up 1. Oops, I don't have the right marker. We're trying to use our marker. Now it'll work. So let's do that again. -3 and 4. Put a dot there. Put a dot at 2 and 1, over 2 up 1. And put a dot at -1, -5. So -1, 1, 2, 3, 4, 5. All right, there we go. So let's draw a line between those objects, or those vertices. And so this green one, these green dots and image would be the initial image, and then the red dots would be the new image. So the pre-image and the new image. So that's the gist of this. Now what if I multiply by a scale factor of 1/3 instead of an integer, or 1/2? Let's try this one where we're going to multiply by 1/2. So basically we would look at all of the numbers that are in our initial image and we would divide them in half, because that's what multiplying by 1/2 does. So let's do that. So 1/2 times 8 would be 4. 1/2 of -8 would be -4. 1/2 of 16 would be 8. 1/2 of -6 would be -3. 1/2 of 18 is 9. And 1/2 of -14 is -7. 1/2 of 10 is 5. And 1/2 of -16 is -8. So there's the coordinates of our new image. So if I were to plot those, 4 and -4, 1, 2, 3, 4, 1, 2, 3, 4. 8 and -3, so this is 4, 5, 6, 7, 8, 1, 2, 3. 9 and -7, so 9 and 1, 2, 3, 4, 5, 6, 7, -7 right there. And the last one, 5 and -8. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So you have to do a little counting. And be careful as you go. Grab our line tool. Let's connect our dots. So we have looks like a nice little square or parallelogram or something like that. Okay, let's do that one more time, but this time we're going to do our initial image or our pre-image. So I'll mark that with red dots this time. So the initial image was 8 and -8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 and -8. 16 and -6. So 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6. 16 and -6. 18 and 14. So if this is 16, 17, 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 10 and -16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16. Okay, so there's this is the original image where it would have been, and it's looking something like this. So you notice that it's bigger than the new image, because the new image has cut it down to 1/2 the original size. And you notice in this case that it's not they don't overlay each other the way this one worked out. So some of them kind of overlay each other like this one. Some of them don't, depending on what you're given to work with. So you have a few of those to do on your assignment. So let's get them done. So you got like 8 of them. So your worksheet looks something like this. And actually this has 6 of them. Let's see if we got another page here. Yeah, you got 12 of them. So good luck. Not all of them are the same. Some of them you're just asking what's the scale factor. Or in some cases you're given an image and then you're just asked to graph the image of the triangle after you enlarge it or shrink it by the scale factor. So same kind of information, but presented a little bit differently. So good luck. It's called number 45 Dilations on Alex. And thank you very much.